So let's go over to models and LLMs. So I will try to cover some healthcare NLP and large language models that we built at Johnson Controls with through all these projects, hundreds of customer-facing projects that we forged so far. We have two eras, right? So you might say that why at Gen AI era, why do we still need NER models, name and entity recognition models? Because I can just dump this sentence to an LLM and then extract everything that I see on this image, right? Like extract the assertion status, nomad code, ICD-10. But that's a misconception. If you are using LLM right now, you are relying on its own parametric knowledge because it is the representation of entire world, like all the tokens that it's trained on, like a web data. So there is no selection of the data source. They have some data creation that they apply, of course, but you might end up with a SNOMED code probably learned from Reddit post. You may never know that, especially for this kind of mapping. And if you are not rich enough to deploy large, like 300 billion size of model, you are probably using 70B, 50B, 30B size of models. Their medical terminology mapping is quite low, for instance. Or entity extraction capabilities are quite low because whatever you called as a symptom might be a sign for another healthcare institution. Whatever you called as a clinical finding might be named another one, right? So that's why you need small size, maintainable, fine-tunable models on your own infra. That's why we have more than 2,600 pre-trained models and pipelines still you can use. Of course, we are using LLMs as well, right? On the left side, we have different solutions like total patient journey, generative AI lab, etc. And we have different size of models as well, like specialized small language model, which is less than 10 billion size, that you can go ahead and then use with the same library that you see on the right-hand side, which means that we have LLMs to extract entities as well, but we fine-tuned that LLM to extract entities. So it's not just, we have another LLM just for summarizing the radiology notes, for instance, because if you fine-tune some decent size of LLM for a different task, you can you can reduce the size of the model, as you know. That's why the specialized small language models are doing way better compared to large language models for that specific task, because you cannot just expect a GPT-5 size of model to solve your own problem because it hasn't seen your own data, right? But if you have a small model that is fine-tuned on your own data, own pattern, you can do more stuff than a large model can do out of the box. So we have different size of models, as I said, like a 14 billion to 18 billion size of model. We call it MEDAM, like a medium-sized medical LLMs. They have different license, but we have small language models that you can use as if it's a NER model with the same healthcare NLP library, by the way. You can even extract, as I said, entities with some LLMs if you would like to test. But on the right-hand side, we have, like, we support more than 50 different medical terminologies, for instance, because over there we have a open box pipeline, like we extract the entities, and then we try to map these entities within its context to a certain terminology, because we have a different vector DB for each terminology, by the way, that you can accomplish the same within the same collab notebook that we will provide here. So if you go to Spark NLP workshop / healthcare NLP folder, you will see all these notebooks, how you can do the same. I'm going to upload like a 60-page slide into certification training folder as well. On top of this presentation that I'm showing right now, I prepared another one, which is going more detail into JSL ecosystem and healthcare NLP ecosystem. You can go ahead and then check that PDF as well on your own time. So if we split this ecosystem into 4, the upper left corners are LLMs that we just mentioned, medical, specialized, fine-tuned LLMs. Upper right corners that we have been already developing for the last 7 years. So like they are encoder-only BERT-based models, right? We have encoder-decoder-based T5 and DeBarta or BART architectures as well to do medical summarization, question answering, text generation. Surprisingly, we are still using all these small models without even using any LLMs. For LLMs, we are building some other flows to solve different problems that small models cannot do, right? So if you would like to do build some RAG architecture to talk to your own documents, the other models may not help, but a small 3 billion size of model can be deployed in your RAG architecture. On top of this, we have out-of-the-box solutions as well, which means that we have some certain solutions that we ship out of the box they are already baked in, which means that we build certain solutions to solve certain problems, and then we ship it to other infras as well, like some turnkey solutions, we call them. So if you want to do medical text-to-speech, we have a pipeline for this. If you want to do HCC and risk adjustments, we have another pipeline for this. We have medical terminology mapper. We call it terminology server. So we have web-based, the fourth piece is we have UI as well, like a web-based applications that you can deploy on your on-prem as well. So we have medical chatbot, generative AI lab, terminology servers. Generative AI lab is there to annotate your own data, human-in-the-loop validation, train your own model within the same platform, so that you can, without even writing a code, you can fine-tune any NER model or train any name identity recognition model within the same platform. You can even annotate your data with LLMs as well as your own, like our pre-trained pipelines. We have total patient journey and patient registry products are coming up as well in a few months. It is the pillars. They are the pillar of what we have been cooking here for the last 10 years, by the way. So as I said, everything starts with information extraction in NER, in healthcare NLP, in healthcare AI. And then right now, even the tools and model sizes and model capabilities change. The task is still same. Extract information, extract insights from your own unstructured document. But we do this extraction for a reason, right? We are not just extracting the entities to highlight the text, right? So if we extract these entities, we dump them into somewhere so that we can query, we can build other solutions on top of this. Maybe I'm going to build a total patient journey. I need all this data from unstructured nodes so that I can merge with the structured data and create a new schema, let's say OMOF schema, right? So that I can connect my own solution UI to that DB and then use on the UI. Or maybe I'm trying to automate medical terminology mapping. Maybe I'm doing some insurance claim analysis. I would like to know that if there's a fraud over there, so I can upload a document and then find all the possible ICD-10 codes, HCC codes, right? So to be able to do this, I need to extract all these entities. I need to map them to certain terminologies so that we help human to inject this automation into their workflow so that they don't need to visually check, because sometimes there are thousands of pages to explain what stage 2 means for a certain type of cancer. So that's why the medical coding is a specialized profession, by the way. People get trained to do this. That's why we try to automate all this process. And we already have more than 500 different small name identity recognition model that you can extract all these entities, like more than 500 different entities you can extract. Of course, you can say that, okay, you can just dump this into an LLM and then extract. But if you are doing, let's say, oncology entity extraction, if you have millions of records, if you use LLM for this, first, you need to make sure that whatever you get from there are deterministic, which are not. And then you can scale this over millions of records, which you cannot do with large language models, right? That's why we have solutions on top of small language models and very small classic NLP models like LSTM-based NER models, that LLMs are playing an orchestration role over there rather than handling the data extraction. So LLMs are there to build a interface between you and other AI models. And there are some tasks, of course, that cannot be done by small models. That's why LLMs are there to help you, let's say, talk to your own data, or extracting certain information that can be inferred, right? I can extract all the tumor-related entities, for instance, but maybe there is no staging information over there. But if I instruct LLM well enough with this corresponding guidelines, and then feed all these granular entities that I can extract with NER models, I can help LLM to make that decision so that it can connect to us, right? Because LLMs are like a JPEG images, right? They are zipped version of the entire world, which means that whenever you try to get information from LLMs, you may not know if that's why we call it hallucination, right? So that's why if you add some guardrail to these models with the help of small models, you will probably utilize LLMs way better than out-of-the-box LLM solutions. So we have some benchmarks over there to compare our entity extraction capabilities compared to other LLMs like GPT-4, etc. So as you see, we are already outperforming them on these verticals. We compared ourselves with the cloud providers as well. So because AWS, Azure, GCP, they all have their own healthcare API. And LLMs like Anthropic Sonnet, GPT 4.5 or GPT-5, they have their people tend to upload their documents and extract all these entities as well. We did some analysis on certain entities. We see that specialized small entity extraction models are still doing better compared to large language models. But if this is the goal, if the end goal is extracting the entities, right? But if the end goal is different, let's say summarization, NERs will not help over that. But NERs will help summarization to ground so that the hallucination doesn't happen when LLM summarize this document. So we have a data and the identification solution as well, like finding the sensitive entities and replacing them with the fake corresponding entities by keeping the consistencies. So we compared this against other cloud providers and private LLMs. And then right now, this is the most most robust solution that Johnson Controls is offering right now, because this is the best-selling product, by the way, that we have running the identification solution with many other customers and users around the globe right now. And we are supporting already 8 different languages like Spanish, Portuguese, French, etc. So how we evaluate all these models, right? So there are some evaluation frameworks like Stanford has MedHelm, and then OpenAI has HealthBench, etc. So there are different data sets under each frameworks. For example, for the clinical documentation, there's an empty sample, ACI bench, MEDEC, etc. For clinical dialogue, there's another data set. So that's why there are benchmarked like a test benches that is combination of multiple data set for different medical tests. So we try to evaluate our models, small models, against all these large language models on these verticals. And then this is run, by the way, last week, by the way, GPT-5 versus Gemini 2.5 Pro versus Sonnet 4.5, which are the latest at the time of this presentation, which were the latest state-of-the-art private LLMs, frontier models. We compared our solutions on these data sets. By the way, we are going to provide you the endpoint so that you can reproduce this as well. So we have our, this is medium-sized LLM, without even using any data from these data sets. We built these solutions around some system. As I said, when you talk to ChatGPT, it is a system, it is not the model itself. That's why we have some system built around our own LLMs as well that you can deploy on your infra. These are the metrics. So to wrap up, how we deploy these LLMs, how you can deploy all these LLMs in your on-prem, right? So there are 6 different ways of doing this. We have hosted demo apps that you can just ask us to get an access so that you can test our LLMs on our demo apps as well. We have containerized deployment that you can deploy on your on-prem. Let me turn on my camera so that I can wrap this up. We have containerized deployment, even supporting some like Databricks infra as well, which means that you can just take this container into your own infra and then run with your own data without even letting us know. So we have marketplaces as well. So in AWS marketplace, like you can just pick any model that we offer over there. If you go to AWS marketplace and then search Johnson Controls, you will see all our marketplace models. Of course, it's not enough. That's why we have 200 different notebooks and hundreds of hours of tutorials on YouTube as well, if you would like to learn more. So we have available small models for local use. Let's say you would like to test it on a collab or on your own local laptop. You can test all these models over there as well, by the way, because we have a LLM loader inside Healthcare NLP that you can test this. And we have an API endpoint coming sub as well. So far, Johnson Controls hasn't offered any APIs-based solution because we always claim that, which we still believe, anything that we develop should run on your local with no internet connection. due to the nature of the data. But to make the testing process easier, not building a solution around, just to test this without going into any deployment or any installation process, we will try to offer some API endpoints soon as well, so that you can test all these models remotely with your own non-PHI data, of course. These are the resources that you can go ahead and then use, check out. So we have official documentation, we have getting started guides, we have learning hub, so we have Medium publications, we have deployment guidelines, so you can go ahead and then check all these links as well. If you would like to learn and solve solutions, of course, it may not be easy to find your way around all this documentation. That's why we have a strong support channel like Slack channel, email channel, etc., so that you can ask questions, so that we can point you to right resource. So far, I tried to explain what you can do with the small language models versus private LLMs versus open source LLMs, right? So this deck is there to compare when to use small models, even without any LLM, like just simple relation extraction model, maybe assertion status model, versus LLM. So I try to cover on this deck, so you can go ahead and read all this. I hope you enjoyed this